Here we are talking about securing modern API and microservices applications. Jonathan gave me a great introduction, so I'll just skip this slide here. This presentation is supposed to provide you with an overview of this subject matter and architectural takeaways. Just out of curiosity, how many of you are working in a security engineering position dealing with API security and that sort of thing? Cool. A fair number of people. That's great. And so, yeah, the material in here is the result of about 4 years or so of me working on this stuff as I was working with HSBC globally, and they were moving from monolithic application architectures and service-oriented architectures and going into microservices and opening things up with APIs. There was a lot of learning involved, and it was fairly new territory, especially for a bank. So during that time, I learned a lot, and we ended up creating a lot of architectures, and some of them are fairly complex, as you can appreciate. In a HSBC being third largest bank in the world at the time, they had a fairly heterogeneous environment with lots of applications of all kinds of shapes and sizes, and having to make all these things work together across different lines of businesses. It was a challenge, but there was a lot of lessons learned, and I'm hoping that I can share some of that with you. So what are we going to talk about? This is our agenda for this presentation. We're going to start just sort of level setting, right? I don't want to just jump right into the security side of things, because often I find that some of these topics are not well understood, and there's a lot of confusion, especially when it comes to what is a microservice, the difference between a service and a microservice, what's a service-oriented architecture, what is an API, right? People that have sort of started in this field recently, there's also a fair bit of confusion in that area. So I want to level set on those topics, and then we get into the nuts and bolts of what this subject is about. So then we start talking about how API gateways can help you in this post-monolithic world. We're going to talk about why it's important to have user-level security context and end-to-end trust across the entire journey, because once you break things up, functions are all spread all over the place, and you need to ensure that you maintain that trust across the function calls. We're going to quickly talk about why do you need authorization. And we're going to talk about what authentication and authorization protocols you can use. I find also there's a lot of confusion in that space as well, so we want to discuss that. Then we talk about how you invocation by external applications. So that's great. You broke your application into a bunch of microservices. How do you deal with other microservices calling your microservice outside of your trust boundary? Then we'll talk about what other security concerns should you care about aside from authentication and authorization. And in addition to that, other important things like logging and monitoring and detection controls that are still important in this world of microservices and modern applications. And then, of course, the importance of group policy, and then we'll finish up with some takeaway considerations, a summary of when you leave here, what should you be thinking about and how you can action on some of these items. So what are microservices? So I always like to throw a Wikipedia definition to start the conversation. So as Wikipedia says, quote, microservices are a software development technique, a variant of the service-oriented architectural style that structures an application as a collection of loosely coupled services. In a microservices architecture, services are fine-grained and protocols are lightweight, right? So that's the Wikipedia definition. So let's dive into that a little bit. So you're hopefully familiar with monolithic applications, right? Monolithic applications, everything is tightly coupled together inside one application trust zone. And essentially, they don't scale very well, right? All your functions are together. If one of those functions is more often used than others, well, you can't, it's not separated, they're all together. So you have to deploy, when you're scaling, you have multiple copies of all of that stuff. Not so good for scalability, especially when different components have different resource requirements. And often, monolithic applications can get really large and complex to be understood by one developer, right? So one person looks at it, there's usually often hundreds of people work on these applications, and they grow to be fairly large. And they don't protect components from other components' issues. So inside that bit, if there's a vulnerability inside one set of functions or component inside that application, it might impact others because they're all tightly coupled in a monolith. And they're difficult to rewrite if you needed to adopt a new framework. So lots of issues with them. So the general move in the modern times is to re-architect these traditional monolith services and applications, right? And essentially, applications and services are decomposed into smaller microservices. So here on the left, we see a monolithic application where you've got 6 different functions or services all tightly coupled in one trust boundary, and then they're talking to a data source. And then on the other side here, we've got microservices-based application where we took similar functions and we broke them up into microservices, typically hosted in containers. It doesn't have to be, but that's typically the model in the modern applications. You break them up and then you put them in containers, and they also have their own data stores that they deal with. So, in the late 90s, there was this whole talk about service-oriented architectures. I got kind of involved with SOA in like the mid to late 2000s. But the whole idea was that you take enterprise applications and you look across the enterprise and you find, hey, I have like this application over here and I have this other application over here, and they seem to repeat business functions, right? In application 1 in the bank, we had some CRM functionality and some sales solution functionality and some other stuff, and then we had another application here that had the similar, like it also had a CRM piece, and there was a lot of repetition. And I think IBM was one of the first companies that did an analysis across all their enterprise applications, and they had thousands of applications. And they found that across all those applications, there were only 40 services, 40 business services, and those services were often repeated amongst all these other monolithic applications in their organization. So they started to say, okay, well, what if we just made 40 services and then leverage those services to create new applications and be able to service different channels. And that's where the SOA movement, it gained a lot of momentum in the early and mid 2000s when web services and other technologies came about. But typically in an SOA architecture, you had services communicating using an enterprise message bus and using the SOAP and XML. And SOAP and XML are fairly heavy. For those of you who've been lucky or unlucky to have been in that world, you'll know that you have large SAML tokens, lots of complexity, and it was fine for enterprise environments. But once you went to the internet, that wasn't so acceptable. You have to have lighter weight protocols, and you can't have these large SAML tokens that don't even fit in the HTTP header. So you had to go towards, there was a move towards lighter microservices. So the microservices architectures, they're also made up of loosely coupled components, similar to service-oriented architectures, but the composition is a little bit more granular. So whereas a service, you might have a messaging service, right? In a service-oriented architecture, you could further take that messaging service and break down its functions, like sending a message or queuing a message or doing some other functions within that messaging service. Or if you had a CRM function, a CRM service in the SOA architecture, you could break that CRM service into smaller functions. So within a CRM, it could be like user management and contact management and company management and lead management and that kind of stuff. So each microservice delivers a specific function. It's more fine-grained than SOA, and they typically also they typically communicate using an API gateway and HTTP as opposed to the heavier SOAP and SAML. So here are a few things about microservices. They're typically hosted inside containers. Again, they don't have to be, but typically they are. And containers are lightweight and they don't have a lot of overhead. And typically these things are exposed via APIs, and either directly or via API gateways. A lot of clients that we deal with, they seem to just expose things directly. But as we can see, there are a lot of advantages for leveraging API gateways. And they use lightweight protocols like HTTP and JSON, and not all microservices are exposed by API. So it's a false assumption that just because I have a microservice, it's going to be in a container and it's going to have an API. You could have microservices that aren't exposed by APIs that are still microservice, and they deal internally, that are dealt with internally. They're not exposed using an external API, I should say. And each one can be independent. It has its own database, as we saw in the previous diagram. And that allows decoupling from other services, and it's well suited for agile and CI/CD environments due to its lightweight nature requirements. But it brings a new set of challenges because you get, as you can appreciate, once you when you take loosely coupled monoliths and you break them into once you break the tightly coupled monoliths into loosely coupled microservices, you get the distributed systems complexities, and maintenance of data consistency across microservices becomes an issue because now each of your microservices has got its own data store. How do you make sure that, if you've got the account management microservice in your CRM, and then you've got like your lead management microservice, the two of them oftentimes will need to have information across the different microservices. So data consistency becomes a problem. And deployment is also a challenge and increased memory consumption, because before all those functions were inside a tightly coupled space, they shared the memory, and now you're breaking them up into individual services that might, that increases memory consumption. So those are just additional challenges. What about APIs, right? APIs have been around forever. I mean, I've been programming since the late 80s, and APIs are not a new concept, right? API simply just means it's an application, again, back to Wikipedia. In general terms, it's a set of clearly defined methods of communication among various components. A good API makes it easier to develop a computer program by providing all the building blocks, which are then put together by a programmer, right? So my first exposure to programming was C and C++. And of course, you had APIs, right? You expose. It's all about abstraction layers, right? Even in telecommunications world, where I spent years doing application development, you have abstraction layers, and then each layer exposes this functionality to the next layer through an API. Now, unfortunately, people that are sort of new to this field, that have only been doing this for the last few years, they automatically associate APIs with web technologies, but API is just a generalized concept. So now, how do we take that into what we're talking about? So it's API is used by software components to communicate, been around for a long time, and can be used to build components that work together. Inner working knowledge of other components is not required, right? So you just expose your API, and this is these are the methods, and these are the attributes, and that's all the other user needs to know. They don't need to know what is happening inside that particular component. And you only need to know what functions are exposed, and that's good separation. So here you can see that service A is consuming the API that is exposed by service B. And many modern applications are web-based in 2019, and they expose web APIs using HTTP and JSON, typically RESTful. But again, 90% of clients that we work with, when I say, hey, are you using a REST API? They're like, yeah, kind of, right? And what they mean is they're not fully REST compliant. They are using HTTP and JSON, but the rest of it is sort of up in the air, right? To be fully RESTful, you have to support push, post, get, and all those kinds of things. But the verbs have to be HTTP compliant. But these companies often come up with their own verbs and nouns and all that kind of stuff. But web APIs can be typically RESTful and follow resource-oriented architecture, and they can be used to communicate to other components or functions. Either it could be inter-application, so if you have application 1 or 2, they could be communicating between them, or intra, so it could be, inter-application within that application or across external components or functions. So what is an API gateway? How does it help us, and how does it fit into this post-monolithic world that we live in? So monolithic applications, as we talked about, all the functions live inside the same walled garden, right? So you have a walled garden, and you've got all your functions inside, and they're all happily living together. And then users authenticate through the front door of this walled garden, and once they're authenticated, then they just float around. The functions call each other, because you're assuming that this, the walled garden is keeping all the functions securely inside. And that's great for a monolithic application. It's protected by a single point of entry. Once you enter through, then you make function calls across. And user journey typically doesn't require further authentication. Now, there are exceptions, like in Java, you can enforce additional authentication and authorization requirements within function calls, but as a generality, with a monolithic application, you enter the walled garden, and then you're inside, and then everybody, you're inside that trust zone, the application trust zone. And functions inside cannot be invoked by the outsiders, typically, because you don't expose them. And authorization can happen at the gate or at the functional level. With microservices, there's no more wall with a single point of entry, right? You took that walled garden, you removed it, you took all those functions, and now you kind of put them all on their own in their own containers. And these functions, before they were protected by the entry point of the application, they need protection. So what do? Are you going to get the user to authenticate every time they're trying to access one of the microservices? That just doesn't make any sense, right? So you need new ways of doing things that still sort of create that virtual walled garden, so that these microservices that belong to the application, there's still a sense of, yes, these things all belong to the same application, and you can enforce similar policies when it comes to authentication and authorization and other security requirements. And each, in a microservices world, each of those can be accessed via its API, and you need to ensure that their user is authentic without full authentication. And I tend to use the term heavy authentication. That's when the user has to provide their username and password and go through all of that stuff. Right? And so you need to make sure that you can do that without having to go through that heavy authentication for each microservice. So here's just a picture. You can see you have different channels. You have a mobile client, a desktop client, other external services. They go through an API gateway, and there's several microservices, each with their own database, and you can even have further granularity if you wanted to. So what are the security benefits of using an API gateway? Well, it acts as a single point of entry, so it kind of emulates that walled garden single entry point that we had before, right? So we kind of now broken things up, but we like the fact that before our application had this wall protecting it, so we put a single point of entry by we could leverage an API gateway for that. So it acts as a central enforcement of security policies like authentication and authorization, and it guards your APIs and microservices. Now, again, you've put this guard around them. And what you got to do, though, is you got to make sure that in order to make that guard complete, you got to make sure that those microservices, for someone to access them, they have gone through that API gateway, that there's an indication, they've got a token or something that says, hey, I went through the API gateway and I got this token, now I can come to this, talk to this function. And that's how you emulate the previous walled garden. And you can issue, API gateway can issue tokens once security policies are met. So, once you go through that gateway, it's like, okay, these are the policies. You have to have multi-factor authentication. You have to, it applies JSON threat protection or XML threat protection or whatever those policies are. Once you pass those policies, then you do the heavy authentication, and then you get a token. So you should use an identity and access management service to properly handle authentication and authorization. I see oftentimes people just use Nginx as a reverse proxy, and they kind of use that as a pseudo API gateway and try to do some of the authentication locally. It's a good idea to tie that in to an actual IAM service, whatever that may be, if you want to use third-party identity access management or identity provider services to do that, that would be great. And tokens, then the tokens are issued that can be used for light authentication and authorization when accessing those microservices. So at the gateway, the request it arrives there. The gateway talks to an identity provider, an IAM service, says, hey, this is Farshad. He's trying to access this microservice and do X, Y, Z. And then, if you pass the policies and everything is okay, you're given a token that can be your token that can be used downstream for light authentication and accessing those. So ID, for example, ID token and access token in OpenID Connect can act as those light authentication tokens. And it lowers the exposure of long-term credentials, right? So you're not passing the username and password all the way downstream for every function call. You're taking that token. That token is short-lived, right? The access token should typically be short-lived for 20 minutes or whatever it is, and then that gets used downstream, and then you're not exposing the username and password all the way. I am actually working with a client right now that you see that they are passing the username and password with every function all the way down the function call. Do not do that, right? Not a good idea. Exchange that for an access token that's short-lived, and then use that for your light authentication downstream. But there are also non-security benefits. API gateway is not just for security. API gateways can expose different APIs for each client. They can route requests to different microservices. So you could have desktop versus mobile versions of stuff, and API gateways can help you with that. And they can create mashups using multiple microservices. For example, you might have a transaction summary microservice, but then in order to show that the user, account balance summary, but you might have checking accounts and credit cards, and those are serviced by different microservices. So your account balance microservice can fan out and go to those different microservices, one on the credit card system and one on the core banking system, and be able to aggregate that and do a mashup and provide you with one set of data that can be used by your application. And it can abstract service instances at their location as well. It can hide service partitioning from clients, which is really nice. That can change over time, and it provides protocol translation, which is also handy. So I just want to talk about user-level security context and end-to-end trust, because that's quite important. And in this world, when we're using tokens, we need to think about those concepts. So in a traditional system, users authenticate to an external endpoint. So you have your application, your typical three-tier application, right? You have your presentation layer, your logic layer, and your data layer, right? The user usually authenticates to the first layer, and then your logic layer just has a service account that connects to the database, right? It doesn't carry that user context downstream. The user authenticates to the first layer, and the first layer, it knows that you're you, but when that layer is talking downstream, it's using a service account connecting to the database, and that logic layer could technically act on behalf of any user, so it could query the data for any user's data. That's not that great. You need to carry that user-level security context, that authentication context, all the way down across the call chain, so that every component that's servicing that call is looking and acting based on the user-level security context, so that you don't provide the opportunity for if someone compromises the logic layer, for example, they can't just go query data for every user, that there'll be this additional protection through user-level security context. context. So that's the problem, is that you get access to all data through that service account. It's too permissive. And that's against one of our favorite principles of security, which is the principle of least privilege, right? You don't want to break that. And you can't do comprehensive auditing of specific actions related to a user either, because every action from that logic layer to the data layer, for example, would be using that service account. So you don't really know who they were acting on behalf of. There's no user-level security context for more granular, comprehensive auditing. So you should establish user-level security context before allowing access, and that should be carried end-to-end, which is this concept of end-to-end trust that we're talking about. And a security token can be used for that, to determine the security context before servicing that request, as I mentioned earlier. So when you go to that API gateway, you do your heavy authentication and the policies are checked, then you get a token. That token is granted based on the scope and based on the resource you're trying to access and all those kinds of things which we're going to talk about, and then that should be carried downstream. And I'm going to give you some examples, and we're going to talk about that a bit more as well. And security token can be used before servicing, and the tokens must be signed and also encrypted if there's a confidentiality concern. So if you don't sign those tokens, then any attacker inside the system could just generate their own token, right? So signing is quite important. Oftentimes these tokens don't need to be encrypted, because you might have things that's just like a claim ID or scope that might not have confidentiality requirements. But if there were data elements that you are including that token for whatever reason that require confidentiality, then you should also consider encrypting them. And API invocation may involve calls across several downstream microservices, right? So if you have a simple application, the user is just going through the gateway, they're calling one function. But the example that I gave, when you have a mashup microservice, that microservice is going to call two other microservices, right? So your application in the presentation layer is saying, hey, show me all the account balances for every account that I have. That first microservice receives that request, but that needs to fan that out to more microservices downstream. So in order to do that, you need to ensure that the authenticated user's security context is communicated end-to-end, which is the end-to-end trust concept. With that end-to-end trust concept, you communicate the authenticated user's security context to all parties across the journey, and then each party can take appropriate action based on the user's context. And you can exchange that. You can use a token exchange endpoint or end-to-end trust tokens, and we're going to talk about that as well. But don't forget that you also need service-level mutual authentication in addition to that. And the thing is that a lot of people say, okay, great, in the old model, we were using service-level authentication, right? You had your logic layer communicating to the data using a service account. Everyone's familiar with that, right? ODBC connections, JDBC connections. So that was not that great, as we talked about, because there's no user context. Now I'm seeing what's happening is the opposite. Everyone's like, oh, great, I got an access token. Let's just do away with that user-level security, the service-level security layer that we had. That's also not that great. That's fine. The argument is like, well, if you don't have a token, the service won't service that request. But the counter argument to that is, well, that token can be stolen, and if anyone captures that token, they can talk to that service. So you still want to limit which other components in your application can talk to that service first, right? So you first need to go, hey, I've got a service here. Which of other services are allowed to talk to the service? And then we establish service-level trust, and then you go, okay, cool, you're this other component, you're allowed to talk to me, now give me a token, right? You shouldn't just accept that token from anybody on the network, because if that access token is compromised, anyone can play that back. So that can be handled, that can be mitigated by using overlay networking, like VXLANs. A lot of these container ecosystems support that. Like Kubernetes, you can create clusters and tightens the networking amongst your different microservices. You can also implement mutual TLS, but it's not for the faint of heart. Because as you can imagine, you're going to have all these components, and you have to do all kinds of complicated PKI, and you need a public-private key for each of your microservices and try to manage them. I tried to go down that path, but it was like kind of scary, and we kind of quickly retorted. And again, one of the nice things about Kubernetes and these modern container orchestration and management systems is that they provide some of this for you, so that you can create these overlay networks and tighten things. And you can also use your service account and TLS, as long as you accomplish the objective, right? It's always about what objective are we trying to accomplish? The objective is having these microservices that belong to this application should only be talking to each other. You shouldn't have a random rogue service try to talk to them, and there are different mechanisms. But don't forget about service-level authentication, because you have a token now, right? That's the message that I'm trying to convey. So there's two different ways you can do this. You can ensure that there's end-to-end trust across your call chain. One is to use a token exchange endpoint. This is the preferred method. So services exchange a token for another one. So you go through your API gateway, you reach your account balance microservice. This account balance microservice now needs to go to two other microservices. So then this account balance microservice can take a token that it's got, go to a token exchange endpoint, say, hey, I need to make a downstream call to the, the credit card balance microservice. What do I do? And this is the resource. I'm trying to, my scope is I just want to do read-only, and this is who the user is, and you exchange, and the protocol downstream is XYZ. Then you get a new token that's suitable for that protocol and suitable for that next, the next call in that call chain. This limits the amount of access granted and allows for heterogeneous protocol use, right? It's really nice because if the protocol downstreams happen, if the upstream protocol was like, let's say you were doing, it was RESTful with JSON and HTTP, but the next microservice was an old one that supported, it needed a SAML token. The token exchange point can handle that for you, right? You can go like, okay, here's a token that I got, but I need to talk to this guy who needs a SAML token. The token exchange endpoint can generate one for you and let you go about your business. And this may be also handled by the same endpoint that issues the initial security token. So it depends on your architecture. You could have a separate security token exchange endpoint and then another one that API Gateway deals with initially for that first token generation, or you could have a service that provides both token functionality. And each microservice verifies the token and provides access based on the context and claim and scope. So when you have this new token, then it goes to the next microservice. They kind of look at these attributes, and then if the token's valid, they provide access. You can also use end-to-end trust tokens. I've seen some architectures that do that. It's a bit limiting. Those things, you can generate an end-to-end trust token at the gateway after the initial set of policies are enforced. So when the user passes whatever the security guard at the gateway is enforcing, then you get this token. But the problem with that is all your downstream services need to have the same scope. Scope and protocol, right? Because you've generated a JOT token. Well, everybody needs to accept JOT tokens. If you have one service that's using SAML in that call chain, it's not going to work. So it really requires a homogeneous set of services, and also requires policy knowledge, because now you don't have this a token exchange endpoint that looks at the policies and looks at what this service wants to do and then it grants a token. You're not doing that. So each microservice has to have that policy knowledge. Okay, well, who is this guy? What is the policy? What do I need to do? And then enforce it. So you're moving that from a centralized policy knowledge and policy store into more of a distributed one. So here you can see an architecture with a security token service and a token exchange service. So you have your API gateway, you have your user interface, the user makes the call. Here you would go into your security token service or your identity access management, you do the heavy authentication, you get that initial token, you go to microservice 1. When microservice 1 needs to talk to microservice 2, it can go to the token exchange service and get a new token and come back and fire it off at microservice 2. That's for that architecture. So user-level end-to-end trust is established among microservices of the same application or service, right? So we had this monolithic application, right? Before, they were all inside this walled garden, all the different functions lived happily ever after together. You broke these out, but they still belong to the same application. They can be used by other applications, but technically they're in that, they're trying to perform functions that ultimately roll out to this application. And they're all in the same app. We call it an application trust zone. So they use the same identity provider and the same policies, right? Because they are part of that application. But what if you need to access microservices in another trust zone, right? You got a bunch of other microservices and they belong to another application or service, but the whole point of breaking these microservices out is that you should allow reuse, right? I mean, that's one of the beautiful things about breaking things into sort of a loosely coupled architecture, is that perhaps there's a function in that other application that would be useful to you, right? But that function sits in a different trust zone, guarded by a different identity provider and a different set of policies. So how does one microservice from one call another? So you need to go through an API gateway if you are hopefully using that for that microservice. So essentially, your microservice is guarded by your trust zone and your identity provider. You're going to call this other one, you're going to have to go through their policy enforcement and their API gateway. So you can accept a security token if there's a trust relationship, right? So similar to You know how we do things in like an Active Directory, or we create domains of trust between two different domain controllers, right? Similar idea here. You can establish trust between those different identity providers, and then end-to-end trust tokens, though, they need to be reissued because they carry specific contexts and specific resources that they're permitted. So, but you could, if you have the trust relationship established between the two different identity providers, at least the identity context or the user level security context could be transferred without having to go through the heavy authentication again. Again, very similar concept. We have domain trust in Active Directory and things like that. So let's talk a little bit about authorization. We've kind of touched on this, but I wanted to just delve in a little bit deeper. Each microservice may have specific authorization requirements, right? So when you get down to the bottom line, you might have like general authorization requirements at the gateway, say, hey, you need to enforce XML threat protection or JSON threat protection. You might have rate limiting. You might have two-factor authentication. Those are like your application level policies, but that get enforced, and there's some authorization. But it's sort of at the gateway, it's very high level. When you get into each microservice, for example, a bank account microservice to only allow read operations to a checking account for a specific user that is authenticated with basic authentication. But if you want to actually do some read-write functionality to change that balance, you might need two-factor authentication, right? So there are different, in this example, there are different authorization requirements based on what you're trying to achieve. And a security token service can issue a token based on the resource requested. So it could say, hey, I'm trying to access this particular endpoint. This is the scope. So my scope is read-write, or it's read, or whatever that might be, and the user's security context. So it could take all of those things into account, and based on those factors, it could give you a token, and that token can then be given to that microservice. And if the microservice verifies the signature, so yep, I accept this token, then it allows permission based on the attributes that are inside that particular security token. And the token's claim can include things like end user and issuer's identity, right? It can include identities of specific consumers. Hey, this token can only be used by this consumer, not by everybody, right? So if someone stole that token, maybe that would be a good mitigation for that. And also expiration time in there as well. And each microservice verifies the authenticity of the token first, as I mentioned, and then access is provided based on valid authorized claims and scopes that are specified in that token. The microservice itself doesn't have to go and do the policy. It doesn't even have a policy info, right? It just says, yeah, I was able to, the signature match, this is good. It was issued by token exchange endpoint. I'm going to just trust that I can service this user for this read request or read write request, right? The opposite of that would have been if you weren't using a token exchange endpoint, then you would have to have your own policy store at your microservice level and figure out, okay, well, it's Farshad and he wants to do read write operation on this, and then you'd have to go to a policy store and figure out whether that's allowed or not. So you can do that centrally by using that token exchange endpoint. And so yeah, using a single end-to-end trust token, each microservice needs to handle their own authorization, and it requires policy information at that level and becomes a bit more difficult to manage. The token exchange service can be used to obtain a new token for downstream calls, and it allows more flexibility and better access control. So what about authentication and authorization protocols that you can use? So SAML is one that a lot of people have heard about. It's been around for quite a while. It's used for authentication and authorization. So you can do both of those with SAML, right? It's a protocol that uses XML, and it's XML based, that it uses SAML tokens and the SOAP protocol. It's fairly heavy, as we mentioned earlier. And then when the web world was gaining traction and people wanted to do these kinds of central authentication, OpenID came about, right? OpenID, though, is no longer, it's been deprecated. It's now been replaced by OpenID Connect, and it only did authentication. So there's a lot of confusion about OpenID and OAuth and OpenID Connect, and I'm hoping that at least through this one slide I can kind of clarify that, because I've worked with a lot of developers who are like, yeah, we're doing authentication, we're using OAuth. I'm like, OAuth is not an authentication protocol. OAuth is supposed to be used for delegated access. If you should be using OpenID Connect. So, but this is like 80% of the clients we work with, they totally have this wrong. And even if they say that they're implementing OpenID Connect, they don't really know what they're doing. They've got an access token, they're putting it in the wrong place. They've got refresh tokens, they're not sure what to do with it. The refresh token and the access token are sent to the same endpoint. Tons and tons of confusion, which results in a lot of vulnerable applications. So I want to make sure that at least you guys that are in here, one of the takeaways can be that you understand when to use one of these, and then you can go and read further about them and make sure that you're using them correctly. Because using these incorrectly, I think in the OWASP top 10, the authentication and session management related issues are like some of the top ones, and for good reason. And we see those issues across a lot of our clients. So OAuth, latest version is 2.0. It's authorization only, right? So that when you get that access token, it's supposed to be used for access delegation, right? The real, the intention of it was that you had a service and you had another service. Farshad would grant access to this service so that it could call the other service on your behalf. That's what OAuth was designed for. And you can use JWT tokens if you want to. The original spec only used bearer tokens. There are no opaque bearer tokens, but there are extensions to that allow you to use a JWT token and put more stuff in there. And then came OpenID Connect because people were like, well, it's great that you have authorization and you grant access. Farshad gives access for LinkedIn to go to his Gmail account and suck all my contacts and email them all and add them to LinkedIn, right? If I permit it to do so, that's one of the use cases. But what about the authentication? So like you need the full package, right? As we mentioned earlier, authentication needs to happen first so that you establish identity, like that Farshad is who they say they are, and then once I say I'm Farshad and that's proven, then we go to that access delegation part, right? So OpenID Connect was designed to solve that exact problem, to do both authentication and authorization. So it's an extension of Auth 2.0. So all the authorization code flow and implicit flow and all those things that you have in OAuth, you have them in OpenID Connect. It just adds that extra couple of steps to do the authentication, and then you have this nice ID token that proves your identity and it's got your claims. Yeah, this is a JWT token, and here's your identity, and so on and so forth, and then you can go about your business. So it supports ID and access tokens as such. What about invocation by external applications and services? So far we've been talking about all these microservices talking to each other and everything within a call chain within that application or service space. But what if we want to have other external applications or services call our microservices? So APIs may be invoked by services outside the trust boundary of that application. So as I mentioned earlier, you need to establish trust between the two domains and verify the authenticity of the user's security context presented by the token that they give to you. And the API gateway can then issue a new security token for downstream communication, and security policies across the two applications may be different, as you can appreciate. And so you should not accept security tokens from another service without reinforcing your application or your microservices set of policies before you allow access. So should only be issued if appropriate security policies pass, and without central handling, each microservice would need a trust relationship with external consumers, ! Right? That makes it a bit of a nightmare to try to have, you got all these microservices, if you don't have a central enforcement point, how are they going to all live happily together? And it's going to be a challenge. So what about other security issues, right? What else should you care about? So all we've talked about so far has been authentication and authorization, which is quite important. But there are other important things that API gateways can help you with, and you need to take into consideration when you're building your API-oriented, microservice-oriented application. And one of the top ones is rate limiting, right? It's in the ASVS. If you look at the OWASP ASVS, they recommend, there's several different controls in ASVS that are related to rate limiting. You have JSON and XML threat protections. Again, XML injections and those types of attacks can be mitigated through those policies. And you can also create your own custom policies to address other security attacks or specific needs, right? That's the beauty of doing things centrally, because you can create these policies and then roll them out to your developers, and you provide built-in policies to developers, which eases the development process and avoids the learning curve, right? So when I worked at the bank, we had like thousands of different applications and all these different developers, and we had a few security people trying to help all these guys, right? And if you leave that up to them to build their own security policies and figure it out, they're all going to do it differently, right? And at some point you create security patterns and architecture patterns, and you give them those patterns, but also when they implement the patterns, they may not implement them properly. But if you just have a central policy enforcement point and you work with the security team, works with them, and you develop that once, and you put that in there, then the developers don't have to worry about that. They will focus on building the business functionality, and then you go, okay, I'm deploying my application into this into this platform, and there's an API gateway, and it's application type 1. The policy's already been approved by the security team. You just roll that out. There's a bunch of policies that they can select from. It makes life really easy, hopefully. That's why I said hopefully, but not always. So you can avoid learning curve and mistakes by the developers by doing it once and having it approved. There's also logging and monitoring and detection controls that you shouldn't forget in this modern world, right? I mean, these are always important security controls and considerations. APIs should log important events, including security events. So logs should be centrally aggregated, correlated, and monitored. It goes without saying, this is nothing unique to this particular architecture. These concepts are important across all of the domains of security. And success or failure policy checks should be logged, right? So if you are enforcing them, say, at the API gateway, if you're getting a lot of failures, it's like, well, that maybe someone's attacking your application. So you should definitely be logging your policy failures. And other info that's useful in other info can be useful in a denial of service protections and better understanding and profiling the system. For example, how many API invocations per second? What was the response time? So those will also help you do some analysis and better protect yourself. API logs can help with fraud prevention as well. So for example, providing info about which consuming devices and location that can be sent to a fraud analysis engine, and if that is a concern, and further analyzed. And group policy, again, this is not a new concept, right? Like those of you who've been like Windows admins or done that kind of stuff, it's like you never assign access per user, right? You never do that. That's just a bad thing. You create groups and roles, and you assign access based on groups and that kind of stuff. And there's no exception here either, right? You took your monolith, and they were all living in this walled garden, and they had the same policies applied to them. Now you're breaking them up, right? So what are you going to do? You're going to go assign policies individually to each one of them? No, that's like assigning policies to each user in your Active Directory, right? You don't do that. You create a group, and you apply policies centrally. So that's one of the nice things that here you should do as well. You should group objects and microservices together and consistently apply the policies. And by doing that, you can meet the particular business needs for a function or group from a security perspective. And you provide the groups to developers along with a service plan and set of policies that they can consistently enforce. And security tokens should be issued, should be valid only for APIs in that group, right? Those of you who've like seen Apigee, Apigee does that really well, right? They've got this concept where you can take your microservices that are related to a particular application, you group them, and then you apply that sort of group level microservice policy. And I've used MuleSoft as well. MuleSoft doesn't quite do it that way. That's where Apigee is really nice because it allows you to easily group and apply things at that level. And for example, if you have an account servicing application, that might be an internal application used by your internal users that need to enforce an Active Directory policy, and it's an XML-based application and it's internal. So your policy would be AD authentication, XML threat protection, rate limiting from an internal perspective, and the rates would be different as if you were dealing with a shopping site where it was an external application, JSON-based, and used LDAP for as a user repository for and for identity, and then in that case you'd enforce an LDAP authentication authorization-based control, JSON threat protection, and rate limiting that's designed to protect it from an external point of view. So what are some of the takeaway considerations when you leave here, right? There's a lot of things we talked about, but if you were to take one picture or one slide with you, this would be the one, right? So the message here is that you should maintain user-level end-to-end trust across the entire journey, right? It shouldn't be this thing where you just sort of authenticate the user at the front, and then behind there, these layers are talking to each other without really taking that user's context into consideration. And you should enforce authorization at the right place with the right level of granularity, right? I mean, it's not enough to say, well, they came through the gateway and I checked some authorization, but what if you had more granular authorization requirements at the microservice level, right? That aren't necessarily related to the other microservices. You wouldn't want to just enforce all the authorization requirements for every one of your microservices at the front door. It's better to distribute them and handle it with the right level of granularity. Quite important, right? Group your APIs to apply configurable policies consistently, right? The consistent is the operative word there. And use an API gateway to centrally enforce those policies consistently. And don't forget to log, monitor, and detect, right? Again, this is nothing new and special, but it's quite important in this sort of loosely coupled world that we live in. And of course, always follow a defense in depth strategy, right? That's like one of the, the 10 commandments of security. Put defenses everywhere that you can, and build security into the service architecture and design. I'm a big fan of security by design. I'm all about security by design. If you put security when you're designing stuff, there's less problems later on. So really build that into your architecture. And unfortunately, like, and this is an unfortunate part of a lot of these agile and organizations that I work with, they throw out the architecture and they start building stuff. And then they get to a point where they're like, oh, I built this monster. And then I'm like, well, there's been no consideration given to this, and you have to kind of go back and fix a lot of things, right? So agile is great. I'm a huge fan, follow it quite a bit, but also architecture is really important. So they go hand in hand. You don't have to throw one out because you implemented the other. Do that sort of architectural considerations of what am I building, right? I mean, yeah, it's going to be agile. In each sprint, you're going to build different things, and those functions and user stories can be discussed. But if you're building an example that I always give is, if you're building a 50-story building, okay, cool, you start building, if you're doing agile, you build level by level and you kind of go up, right? But if you don't give consideration into the fact that you're going to need an alarm system and maybe 2 elevators, and you don't build the shaft for second elevator, and you don't put that conduit, if you build that 50-story building in an agile method, then you're like, oh shoot, I don't have enough elevators. You're going to have to go and dig another shaft for another elevator and put another conduit, right? So those architectural considerations, particularly when it comes to security, no matter what you're doing, agile or waterfall, they should be done up front. How many elevators am I going to need? Am I going to need a conduit for my alarm system, right? Have I figured that out? Then go build it iteratively. That's totally fine. Maybe the business changes their mind about the color of a particular floor, what kind of doors they want. Those aren't important. They can be changed, and that's what agile is great for. But the security things, particularly from an architecture perspective, they need to be dealt with up front. So that brings me to the end of this. I apologize if I've talked really fast. The content of this material, if you're interested in, I wrote an article. It's a two-part article for IBM Developer Journal. You can find it out if you just Google the title of this talk. The IBM article will appear. It's easy to find. And if you have any questions, feel free to reach out. I'm really passionate about the subject, and I've done a lot of work on it, and I'm happy to share that and have conversations with people that are interested. So you can reach out on Twitter or by email. Cool. Well, if there are no questions, thank you very much, and have a great day.